Hello everyone. So today we'll be talking about travel graphs and speed. Okay, so before we move on to travel graphs, let's talk about speed. So what is speed? Is it how fast something goes? Is it how quickly something can go from one point to the other? So let us look at it. So speed. It is the distance traveled by an object per unit time, and it measures how quickly an object moves. And speed is calculated by the formula S is equal to d over t, where d is the distance and t is the time. So now let's look at the formula for speed. As we know, it's S is equal to d over t. So we can construct a triangle like this, where we have d on top and S at the bottom and t at the bottom. So the line under d represents divide and the cross here represents multiply. So I'll show you how this triangle works. We can use it to make any one of them the subject of the formula. We can find the formula for time and we can find the formula for distance. So when we look at speed, what you do is with your hand you cover you first make the triangle, right? And you cover the S, and what you'll be remaining with is d over t. So the formula becomes speed is equal to distance over time, as we saw the last time. Now, if you want to make distance the subject, what we do is we have the triangle, we cover d, and then we remain with s times t. So distance is equal to speed times time. Now, to make t the subject, we basically cover t, and what we remain with is d, and then the divide line and s. So we have d over s. So therefore, time is equal to distance over speed. So you can get any of these formulas as long as you have one of the formulas. So if you have speed is equal to distance over time, you can convert it by making any one of those the subject. So let's talk about units of speed. So speed is measured in meters per second or in kilometers per hour. So you get it from the fact that distance is measured in meters and time is measured in seconds. So distance divided by time means meters divided by seconds. Then the same thing applies if you write it in kilometers per hour. So distance is measured in kilometers, time is measured in hours. So distance divided by time gives you kilometers divided by hours, which is kilometers per hour. So whenever you calculate, always ensure your units are consistent. What that means is if a question has stuff written in meters per second, ensure that you use meters and seconds and you don't use kilometers per hour by accident. So for example, if the speed is given in kilometers per hour and the time is given in seconds, what you have to do is you have to first convert the speed to meters per second so that the units are the same throughout before performing any calculations. Now let's talk about converting minutes to hours. So usually in speed questions, what happens is instead of giving you time in hours, they tend to give you time in minutes. Okay. So we know in 1 hour there is 60 minutes. Therefore, in 1 minute, it's 1 over 60 hours. So you just divide both sides by 60. So you get in 1 minute, there's 1 over 60 hours. That means in x minutes, there is x over 60 hours. So think about it. In 1 hour, in 1 minute, there is 1 over 60 hours. So in 2 minutes, there's 2 over 60 hours. In 3 minutes, 3 over 60 hours, and so on. So therefore, we can generalize and say in x minutes, there's x over 60 hours. Therefore, to find the number of hours given such a number of minutes, we can use the formula number of hours is equal to number of minutes divided by 60. So this can be shortened to n is equal to x over 60. So now let's look at some problems. So here's problem number 1. A car travels from Lobatse to Hebroni in 45 minutes. The distance between Hebroni and Lobatse is 70 kilometers. Find the speed of the car in kilometers per hour. So if we look at the question, we can see the time is 45 minutes and it's in minutes, not in hours. The speed, we need it in kilometers per hour. So the first thing we do is we change this to hours. Okay, so we have the formula number of minutes. So number of minutes is equal to, number of hours is equal to number of minutes divided by 60. So n is equal to x over 60. So the number of minutes is 45. So therefore we have 45 over 60, and that gives us 0.75. Now, since we have the time in hours, we can now calculate the speed. So speed is equal to distance over time. So the distance is 70 kilometers and time is 0.75 hours. So if we do that, we get, let's see, okay, 70 divided by 0.75 in the calculator gives us 93.3. This is rounded off, kph. Now let's move on to another problem. How long does it take a cyclist traveling at 50 kilometers per hour to complete a 5-kilometer cycling course? Okay, so now we have the speed and the distance, but we have to find the time. So as you remember, we had this triangle. If you can do it in your head, you don't have to use the triangle, but then having the triangle always helps. So d, and then your speed there, and time. So we have to make time the subject. So what you do is, after drawing the triangle, you just basically cover t, and all you're remaining with distance over speed. So therefore, the time becomes d over s. So we have the distance in kilometers and the speed in kilometers per hour. So since the units are consistent, we don't need to change them. So therefore, time becomes 5 divided by 50, which is equal to 0.1 hours. Now, usually they may ask you to give you the time in minutes. So if we were going to give it in minutes, we know that in 1 hour, there is 60 minutes. So therefore, in 0.1 hours, that there will be 0.1 times 60 minutes. So therefore, number of minutes is 0.1 times 60, 6 minutes. So therefore, it takes 6 minutes for the cyclist to complete the 5-kilometer cycling course. Here is our final question. So, a high school athlete runs 100 meters in 10 seconds. Find the athlete's speed in kilometers per hour. So this looks like a tricky question because one, we have the distance in meters and the time in seconds, but we're supposed to find the speed in kilometers per hour. So you can do this in two ways. Either you find the speed in meters per second and then you convert it to kilometers per hour, or you convert your values, like your distance here is given in meters, so you convert that to kilometers, and the time is in seconds. You convert that to hours, then you find the speed in kilometers per hour. So let us go with the second approach. So in 1 kilometer there is 1,000 meters. So in 100 meters there is 100 divided by 1,000 gives you 0.1 kilometers. Then we also know in an hour there is 60 minutes, and in each minute there is 60 seconds. So therefore we have 60 times 60 is equal to 3,600 minutes. Therefore, yeah. So therefore we are going to convert 10 seconds into hours. So in 10 seconds, that is 10 seconds is equal to 10 over 3,600 hours. Because if 1 hour is equal to 3,600 seconds, oh yeah, this is meant to be seconds, right? Yeah. If 1 hour is equal to 3,600 seconds, that means 1 second is equal to 1 over 3,600 hours. Therefore, in 10 seconds, it has to be 10 times that, so 10 over 3,600 hours. So now, we can now use the formula, which is speed is equal to distance divided by time, and then we get 0.1 divided by 10 divided by 3,600. Now, okay, let's see how much we get after we do that. So, okay, 0.1 divided by 10 times 3,600. We get 36 kilometers per hour. So therefore, the speed of the athlete in kilometers per hour is 36 kph, right? So thank you guys. That's all for today. In our next video, we'll be covering travel graphs part 2. So in that video, I'll cover on what exactly are travel graphs and how we can answer questions using them.